So here it is. We ask the data owner to choose pseudonyms during setup. At the beginning of time, the data owner will decide, okay, for parts of the document that will potentially get pseudonymized, I want to choose the following pseudonym for them. So for example, the data owner will choose Sam to replace Fox. And then Merkle hash tree will be constructed in a similar fashion, but the pseudonym will be hashed together. So we not only hash the Fox and the random values, we'll also hash the Sam, the pseudonym. And for the parts that will not be pseudonymized, it will be computed the same. We construct the root hash, assign the root hash, and then give everything to the service provider in addition to the pseudonym. Now the service provider will have to pseudonymize Fox with Sam. Essentially what it does is compute H11 just as before, and then give the pseudonymized document, replace Fox with Sam, and then give the rest of the information to the user. Now the following verification is just the same as before. The only difference it's a minor difference. So the user will have to hash H11, the intermediate hash, along with the pseudonyms in order to construct a root hash. Now, so how does this satisfy all our three requirements? Consistency, it is pretty simple because we now ask the data owner to choose the pseudonyms. So we trust the data owner to choose consistent pseudonyms at the beginning of time. And for confidentiality, which means that once you see the pseudonym, you cannot guess the original text. And that is satisfied because the pseudonyms are chosen by the data owner independent of the original text. It is sort of random chosen, so there is no connection between the pseudonym and the original text. And for unforgeability, it essentially boils down to the digital signature scheme just as before. So this is very simple pseudonym protocol. However, there is one thing, is one constraint, that is the service provider will always has to wait for the data owner to choose the pseudonyms. What if the service provider wants to choose pseudonyms on the fly by its own? So then we have even simpler scheme that actually achieve this. So we have what is called Adhoc pseudonymization protocol that allow the service provider to choose pseudonyms independent of the data owner. So we observe this. So imagine you have a very short document, consists of 4 words, A, B, C, A. Now A are identical. I couldn't think of any short sentence that makes sense and also have repeated words. So we'll just use letters to represent this. So now for each word, we choose a random value. But notice that for the identical words A, we choose the same random value. Now this means what? When you compute the hash value, for both the first one and the last one, they will have the same hash value, H00. And then the data owner will do the construction of Merkle hash tree just as before. Now in this protocol, we'll use the hash value H00 as a pseudonym. So now the consistency is satisfied because identical words will have identical pseudonyms, and the confidentiality and the affordability will just as the same, can be proved as before. We also extend this to allow the service provider to compute an arbitrary pseudonym from the hash value. And that is based on a symmetric key encryption scheme, actually. So essentially, the service provider can just get the Merkle hash tree and then choose whatever pseudonyms he wants to have to replace the parts of the document, independent of the data owner. And how this is done is omitted here. If you're interested, I can find more information about this for you. So essentially, in this part of the work, we have verification of pseudonymized document that is pseudonymized by a third party, but the verification is independent of the person that performed the pseudonymization. So next, we move on to the second part of the talk. It's about verification of aggregate queries. By the way, if you have any questions, just feel free to ask. Yes?
Just a quick question. So the pseudonymization, it applies to single words. What about if you have a large paragraph that's been blanked out? Are you going to have 40 pseudonyms
right.
within that paragraph, or is it just going to be?
So it depends. So the granularity of components of the document depends on specific applications. It can be a sentence, can be a word. So if the data owner decides the granularity is a word, then yes, you have to have multiple pseudonyms. Of course, the data owner can say this part of paragraph will have a sentence as a basic component, and then for that paragraph, we'll have word as a basic component. So depend on specific application. I forgot to mention this. Yep.
Based on what you were showing us, I was wondering if you've had issues with possibly dealing with maybe the same word with lower and uppercase letters. I mean, if you're looking at a document from that standpoint, because if you're computing the hash based on the ASCII, the ASCII values are different. Therefore,
will be different. Yeah, that actually is a very good point. We haven't considered that. That's true. It will in that case, you will have a different pseudonyms, and that's a very good point. We'll have to think a little bit more about that. All right, we'll move on. And in this model, verification of aggregate queries on outsourced database, we have basically three parties again. The data owner this time delegates a database to the service provider, and the users will make database queries. And in this case, we focus on aggregate queries because it is quite challenging. Once you have the aggregate result, you may not necessarily know how to compute how to verify the correctness of the computation. And our model actually is quite general. It also applies for non-aggregate queries such as select, join, project. But we're not going to cover that in this talk. So here is a simple example of what kind of query that we consider. Suppose you have two attribute database table, age and salary. The query is sum all the salaries that are above 60K. So the first, third, and the last record are selected, and then the sum is computed. Now, by correctness, we mean that whether the sum 215 is correctly computed. Now, again, we consider privacy. We don't want to give the user the inputs, 65, 70, 80, are hidden from the user. This is for correctness. For completeness, we consider the selection part. So you have a selection clause that is salary above 60K. Whether the numbers that are computed in the sum satisfy the selection criteria, whether or not the non-selected entries violate the selection criteria. So in this case, we have to prove that 50K is less than 60K. So it does not satisfy the selection